Mr. P's Science and Math Podcasts. For more science and math concepts, search me out on iTunes by typing Papapodcasts. You can contact me at mrplieberman@gmail.com. Thank you for watching. Graphing parabolas. Pattern rule when graphing quadratics. Using the 1-3-5 pattern rule for graphing. You've pretty much probably listened to the previous lessons, and we one of the key themes that you've probably heard in these chapters or in these podcasts have been the use of the 1-3-5 pattern for graphing. Now, let's focus more on the 1-3-5 pattern of graphing. We're not going to worry about we are going to look at the A value and how, keep in mind that, if A is positive, we know the parabola goes this way. If A is negative, we know that the parabola goes downward. Okay, so that's really the main focus of the previous chapters, and just how does A translate to widening or becoming narrower depending on what the A value is. But today what we're going to do is we're going to look at, once we've graphed it, then we can identify all that information. So let's look at the rules for graphing and looking at this pattern a little more in detail. So what we're going to look at, before we move on, let's look at what we've looked at in part 1 of graphing parabolas. We were looking at the difference. So here, let me move this over. Okay, let's move this over. So here we have our main original parabola. Y is equal to x squared. And we said that all parabolas are congruent to that. We know that the vertex, whenever our equation is y is equal to ax squared, we know that our vertex is always at 0, 0. Okay? So here we have 0, 0, 0, 0, 0, 0. Now look at the difference in the y-axis from that spot. Okay? Look at how it changes. Okay? Same thing here. Okay? Same thing here. If we look at y is equal to x squared being our main parabola, if we look at the first difference of y is equal to x squared, this is where we got the 1-3-5 pattern. And notice where the 1-3-5 pattern moves or deviates from. It deviates from this vertex. So the vertex is one of the most important points on any parabola. The vertex. Okay? This is the one key term I want you to keep in mind throughout this entire quadratics section. That the vertex is one of the most important points on any parabola. From that vertex, we're going to move in a 1-3-5 pattern. Now, if we look at this 1-3-5 pattern, and we compare it to the 2-6-10 pattern, how do we get from there to there? Well, we multiply by 2. Hence, the A value 2. So the 2 got multiplied by 1-3-5. If we look over here, 3, and we're moving from this difference here, okay, all the way to this difference, 1-3-5 becomes 3, 9, 15 because we are going to multiply that one by 3. So notice, here the value is 1, so 1 times 1-3-5 stays as 1-3-5. 2, being our A value, gets multiplied by 1-3-5 to form 2-6-10. 3 here gets multiplied by 1-3-5 to give us 3, 9, 15. And that's what's going to help us graph our parabolas. So, let's remember the following. Mr. P's pattern rule uses the 1-3-5 pattern based on the differences found in the quadratic function y is equal to x squared. The 1-3-5 pattern is multiplied by the value of A if the A value is not equal to 1. Okay? So if the A value is 2, you multiply 1-3-5 by 2. So if, for some reason, A happened to be 5, Okay, in the example, let's say y is equal to 5x squared, the 1, 3, 5 pattern would be multiplied by 5. Okay, and if you had that kind of graphing space, you'll see how big the points will be, or how far apart the points will be from the vertex. So example here, y is equal to 2x squared, and y is equal to, and we're going to look at a parabola now, we're going to look at this in the upcoming podcast. Y is equal to 2x squared plus 3. Still, it's considered quadratic, but now the a value here, both of them are actually 2. Which means, therefore, the 1, 3, 5 pattern for graphing is no longer going to be a 1, 3, 5 pattern, but it's going to be a 2, 6, 10. Why? Because we're going to take that 2, we're going to multiply it by 1, 3, 5 to give us 2, 6, 10 when we are graphing. Okay, so how do we